Hello and good morning. I hope you all are good. So, in today's class, what we are going to read, we are going to solve questions from laws of motion. Done. As I said earlier, like in previous class, I said I will be starting next class with some question of 2D motion. So, same thing will I be doing. So, I will first start with two questions in two-dimensional motion, and after that, we will jump to laws of motion. Okay, so let's start first with one question here from two-dimensional motion, and this is basically a question from projectile motion. Done. So again, I'm giving you for this 2 minutes. You don't require if you really have gone through this, but I'm giving you 2 minutes to solve it and share me the answer. Okay, if you're getting, take your time and do it. Okay. So as you can see, this is a question of projectile thrown from an inclined plane, right? So there is a plane inclined at an angle 30 degree with respect to horizontal. A particle is projected with a speed u 2 meter per second from the base of plane, and it is being projected with velocity of 2 meter per second from the base of plane, making an angle how much? 15 degree. You can see here. हमें निकालना क्या है? We have to calculate the distance from the base, that is from here, at which the particle hits the plane. So we are throwing a particle like this. So it will go like this, and hit somewhere here. Clear है? So we have to calculate this distance. Done. So if you look at this question carefully, जैसे we have gone through what horizontal projectile very often, है ना? We know formulas about that. So we know formula for time of flight, that is your 2 uy by g. We know formula for range, and that is your ux uy 2 ux uy by g. And we know formula for height, maximum height, that is your how much? Uy square by 2g. So this is the formula that we know for what sort of projectile. If we are throwing a projectile at certain angle theta from the ground, right? And then it is this. Now, suppose Karlo, we are throwing it like this, done, and there is an inclined plane kept here, done. So suppose Karlo, there is an inclined plane kept here like this, done. Are you able to imagine? जैसे देखो ऐसा है कुछ. From here you are throwing, done. So it's landing up here like this. But suppose Karlo, there is an inclined plane here itself, and it is something like this, done. So if you look at it from first perspective, then it is something like it is being thrown at an angle theta from the horizontal, and this is ground to ground projectile. But if we look at it in another way, this angle, say this is alpha, so this will become alpha minus theta. So now we are throwing it at an angle alpha minus theta from this plane, and then it will land on this inclined plane here. It can't go beyond it if there is an inclined plane kept here, है ना? So then projectile will look like this. So how to solve such question, how to solve or how to derive formula for this projectile, right? So projectile thrown on an inclined plane. Done. So whatever concept we have used for horizontal, ground to ground projectile, same concept will be using. जैसे आप यहाँ पे देखो, do one thing, assume it as an x-axis. So this will become what? Y-axis. So we are considering it as x-axis and this as y-axis. Done. So my projectile will it is getting thrown at a with velocity u, making an angle theta with x-axis, right? And it will land up here. अब आप देखो, when it is here, its x or y coordinate is what? 0, 0. And when it will land here, what will happen? X coordinate will be something that is range, and y coordinate will become 0. Done. So here y coordinate is becoming 0, that we will utilize for finding time of flight. तो यहाँ पे आप देखो time of flight, how you will calculate. So time of flight calculation के लिए what you will be doing, write motion along y axis. So y equal to u by t plus half a by t square. This thing you will be writing, right? And if t is equal to time of flight, if I am taking time of flight, then in that time y will become what? Displacement along y direction will become 0. Initial velocity along y direction is how much? It is your u sine theta. Time of flight plus half acceleration along y direction. Now this is an interesting thing. Here we need to deal with acceleration. जैसे यहाँ पे देखो, acceleration due to gravity is in this direction. Then we are dealing with two directions. This is y, this is x. G is not along any of this direction. So we need to break G. Now you break this G. If you're going to break it, draw a line parallel to y-axis. This is this. This angle will become theta. You already know such things. So this is your G cos theta. And this, in this direction, it will be G sin theta. So along y-axis, in the downward direction, acceleration is G cos theta. Along x-axis, towards negative direction, acceleration is G sin theta. So put here u sin theta t प्लस यहाँ ए वाई को क्या रखोगे? माइनस जी कॉस थीटा माइनस जी कॉस थीटा टी का स्क्वायर, राइट? नाउ यू सॉल्व फॉर दिस. ये 0 है, आप इसको इधर लेकर आ जाओ. सो दिस विल बिकम हाफ टी स्क्वायर बाई 2 जी cos theta, right? So 1t will get cancelled. T will become how much? 2u sin theta by g. So this is equal to what? 2uy g cos theta, sorry, 2uy by g cos theta. And for horizontal projectile, it is 2uy by g. Here g is changing. That is g cos theta along y direction. Here, for horizontal projectile, for ground to ground projectile, acceleration due to gravity in the y direction is what? G. That is why in the formula it was G. Here it is 2uy g cos theta. Ab dekho, now we know in what time it is reaching here. In what time it is reaching here? In this time. Sorry. So how much distance along x-axis it will cover in this time? If you're going to calculate the distance, so distance you are calculating along x direction. So write formula along x direction. X equal to kya likhoge? Uxt plus half ax t square, right? And if you are going to write, x will become equal to range. Ux is what? U cos theta into time of flight. In this time, we are calculating value of x. Minus half ax का value क्या था? Minus g sin theta था. G sin theta t का square. So t we already have calculated. T का value हमने क्या calculate किया? 2u sin theta by g cos alpha. Sorry, that was alpha, right? This angle is alpha now. So this is alpha. Sorry, this is alpha. This is alpha. This is alpha, and this is your what? Alpha. Sorry. So this is your alpha, right? And here also this is alpha. Now you can put the values and get the answer. अब यहाँ पे अगर आप values put करोगे तो क्या पाओगे? R equal to U का value is how much? U का value given is 2 meter per second. So U is 2 meter per second. Cos 15 degree into time of flight, that is 2 into 2 into sin 15, है ना? Divided by what you will write, 10 cos alpha is how much? Alpha is your 30 degree. So here you write 30 degree. Minus क्या लिखोगे? Half g sine alpha, that is your 30 degree, into t का square. If you're going to do t का square, you will get 4 into t का square. अगर करोगे तो क्या होगा? 4u square, that is 4 into 4 sine square 15. So sine square 15 divided by what you're going to write? 10 cos 30. So you need to know values. देखो cos 2 cos 15 sin 15 can be written as sin 30, है ना? क्योंकि 2 sin theta cos theta can be written as sin 2 theta. So here it is very simple. Cos 15 cos sin 15 is here, 2 is here. So these three things together will become sin 30 degree. Sin 30 degree value we know half, right? And here also there is sin square 15 degree. Done. So we need to calculate the value of sin 15, and that we can be very easily do. कैसे कर सकते हैं? sin 15 का वैल्यू कैसे निकालोगे? 45 minus 30 करके. You already know this formula, so put the values and you will get the answer. Similarly, you can calculate cos 15 if required. Done. So in such kind of question is very easy, but the thing is you need to write the value of sin 15, and that you can only do if you know these formulas. Done. So sometimes question is easy, but calculation demands a lot more, a bit more, I must say. So in that case, you should be ready for first sin 15 values, tan 15 values, you should be aware of. Done. And that you can do through this form. So I'm not going to exactly calculate. I've given you the things. Now again, take some 2 minutes of your time and do it. Again, this question I included so that in projectile motion, you can learn how to calculate radius of curvature at any point on the trajectory. Okay? Question comes from this portion, and you can see here, question came in 2019 only in GMINS. So it's very important actually to know this. So give a try and let me know if you're getting the answer. Well, let us do it together. So what the question is, जैसे suppose कर लो, this is a projectile motion trajectory, and we have to calculate a radius of curvature at any point on this path. So suppose I'm taking this point. So what I need to do, if my ball is here, the ball we have thrown is here, its velocity will be in this direction. And this is a curve like a structure, right? So this curve will have center somewhere here, suppose. So if we need to calculate the trajectory, what we need to do is we need to see what is its velocity at this point of time. Done. And at the same time, we need to see what, जैसे for a time being at this small amount of time delta t during which the ball is at this position, we can say that it is in a circular motion of radius r if this trajectory has radius r, right? So if it is in circular motion moving with velocity v, v square by r will be equal to centripetal acceleration, right? So this is all we have to do. Now, we can easily calculate velocity at any point on the trajectory. It will have two component of velocity, vx and vy, that we can easily calculate. Now the question is of AC, centripetal acceleration. We all know that when a ball is in projectile motion, and that too in ground to ground, its acceleration is in downward direction and its value is g. So its value towards this direction will be how much? This angle we need to see. If this angle is theta, it will become g cos theta. And g cos theta will become v square by r. Okay, so we need to do this. Now, let's go on to the question. Question kya hai? A body is projected at t equal to 0 with velocity 10 meter per second at an angle of 60 degree with the horizon. Okay. So what is happening? We are throwing it at an angle 60 degree with the horizontal initially. So it is being thrown like this. Now, the radius of curvature of trajectory at t equal to 1 second is r. So at t equal to 1 second, radius of trajectory is how much? R. Neglecting air resistance, taking acceleration due to gravity, this the value of r is. So let us first see the 1 second. At 1 second, my projectile will be where? Will it be in this region or will it be in this region? So that we can easily check by calculating time of flight. So time of flight मैं इसलिए कैलकुलेट करना चाह रही हूँ so that we can draw the correct diagram. Okay. So time of flight simple है, formula याद है तो time लगेगा नहीं लिखने में. 2 into uy is how much here? U, that is 10. Sine 60, that is root 3 by 2 into 10. Done. So this is root 3, that is 1.73 seconds. So definitely it is more than 1 second is more than that of half of time of flight. So at half of time of flight, projectile will be here. And if time is more than half of time of flight, it will be somewhere from O to P, right? So let's take a position. Suppose my projectile is here. Now here its velocity, let's calculate its velocity first. So Vx will be what? That will remain same as Ux, and that is equal to 10 cos 60. So that is equal to 5, right? What will be Vy? Vy will change because there is acceleration in y direction. So Vy is equal to Uy minus, या plus लिख लो, A by T. Now what will happen? Uy is how much? U sine 60, right? U sine 60. So that is 10 into root 3 by 2. Acceleration due to gravity is in downward direction, minus 10, and that is your t. So this is how much? This is your, and t is how much? 1 second. So this is equal to 5 root 3 minus 10, right? This is what we are getting. Now what will be the total velocity? So velocity ka magnitude we can calculate. Total velocity will be equal to Vx square plus Vy ka square. This thing we can do, right? I hope it is clear. So you can calculate this velocity, then that portion you can do. So here velocity value is now known, right? We have calculated it already. Now, what we need to do is we need to see what will be acceleration value, AC value. So at this point, let's see, velocity is in this direction, right? Trajectory, I'm saying suppose center is here. So an acceleration due to gravity is this. What will be angle made by velocity with this direction? Any of this direction? क्या हो सकता है? Suppose कर लो, just assume that कि this angle is your how much? Suppose कर लो, ये vertically downward direction है, ठीक है? इसको horizontal में मान लेती हूँ, ठीक है? Now suppose this angle is your theta, and this is the total velocity. Done. So V cos theta will be equal to to how much? Will be equal to the horizontal component of velocity. And horizontal component of velocity is how much? 5. So compare it with 5. And from here you will get cos theta, that is 5 by p. So you can easily see what will be theta. If you can calculate theta, you can calculate g, because this angle will also become theta. Why? Because this is horizontal line and this is tangent to the trajectory, and angle between these two is theta. This line is perpendicular to the horizontal component, and this line is what? Perpendicular to this radial vector, right? So this angle will also become what? Theta. So this is also theta, g cos theta. Cos theta ka value हमें मिल गया 5 by p. You can calculate from here, right? So we know what? Cos theta. If we know cos theta, AC is known, that is g cos theta. And now you can easily calculate the trajectory. So trajectory will be what? R will be equal to v square by g cos theta. Done. And v square by g cos theta को आप क्या लिखोगे? अभी अभी मैंने बोला cos theta को क्या लिखोगे? 5 by p. So 5 by p. That is vq by 5 into g को क्या लिखोगे? 50. So this is how you will get the answer. VQ you can easily calculate, and that you will get from here. Right? Clear? Any doubt? Anyone? Okay. Okay, so the correct answer will be this. You can simply put the values and get the answer. Now we are moving on to that is your laws of motion. Done. So the very first question is here. Take some 1 minute or 1.5 minute I am giving. Take this much of time and solve it and let me know the answer. Okay. Let me know I'm here only. No answers. Okay. So what is the question here? There is a ball of mass 0.15 kg dropped from a height 10 meter, strikes the ground and rebounds to the same height. The magnitude of impulse imparted to the ball is. Now, what is impulse? Very first thing. So you already know force is written as what? Ma, mass into acceleration, right? Acceleration can be written as rate of change of velocity. Done. And if I write it like this, F dt, m dv को लिख सकती हूँ change in velocity like this. So if you can see here, this is what? This is mv2 minus mv1. If you see carefully, this is final momentum, this is initial. So this is what? Change in momentum. And this term is called what? Impulse. So impulse is what? fdt, या impulse is what? Change in momentum. ठीक है, दोनों ही तरह से देख सकते हैं. So this is your impulse. Now in this question, what you have to do, there is a ball of mass 0.15 kg and it is being dropped from a height of 10 meter. So this is 10 meter का height ले लो. From here ball is being dropped, done. And after hitting the ground, it rebounds to the same height. So it is coming down like this. It is interacting with the ground, and again after hitting the ground, it is going up to the same height. It means its energy is not getting lost, right? क्योंकि जितने height से गिरा था उतने ही height तक पहुंच गया, ठीक है? So its energy is maintained. The magnitude of impulse imparted to the ball is. So how much impulse this ball is feeling or facing or having, whatever is receiving, whatever you say. So what will happen when its momentum will change? Momentum change will happen when it will collide with something, है ना? ऐसे momentum इसका change हो रहा है when it is coming downward because acceleration is there. But when we are talking about impulse, we are talking about fdt, means momentum change when some kind of force from another body is acting, and here another body is your what? Ground. Okay. So what will happen when the means this impulse talks about collision thing, done. So when collision is happening, during that period of time, what will happen? Momentum will change, and that change in momentum is called impulse. So यहाँ पे collision is happening with the ground. So just before collision, what is the velocity of ball that you calculate? So after dropping through 10 meter height, what will be its velocity? So velocity equal to, कैसे लिखोगे? You are dropping the ball from height 10 meter. So dropping the ball means initial velocity is how much? 0. Done. Acceleration due to gravity is how much? 10 meter per second square. We have to take it. ठीक है. Suppose मैं downward direction को negative लेती हूँ, upward direction को positive लेती हूँ. Then what will happen? V equal to क्या लिखोगे? U plus 80. So U is 0. A is how much? Minus 10 into time. Time we don't know. Sorry. So we can't use this formula actually. Let's use an expression where displacement is involved. Because in the question, time is not given, displacement is given. Okay. So this will become how much? V square equal to U square plus 2A. Now, what is this V square? V square we don't know. We don't need to calculate. So V square, U square is 0 minus 2 into how much? 10. Displacement is also in the downward direction, so it will also become negative, that is 10. So what is the velocity? Minus 10 minus minus plus हो जाएगा. So this will become 10 root. Done. So what is the velocity just before it will collide with the ground? Its velocity is how much? 10 root 2 meter per second. Okay. Now just after it what will happen? It has velocity of this much, and with this velocity it will hit the ground, and when it will hit the ground, ground will apply a force on it, and because of that force, its velocity will change. It will become in upward direction, and since it is reaching to the same height, it means magnitude of its velocity during collision has not changed. Done. So before collision, magnitude of velocity is 10 root 2. After collision, it will be 10 root 2. Because of application of force by ground, what will happen? Velocity direction will change. So final velocity is also 10 root 2, but in upward direction. Initial velocity was 10 root 2 in downward direction. So what is change in momentum here? Impulse अगर तुम्हें निकालना है, so you have to calculate change in momentum, and that is equal to mass, that is 15 by 100 into V2 minus V1. So V2 upward direction में velocity है 10 root 2 minus of 10 root. So this became how much? 20 root 2, right? So यहाँ पे आप क्या लिखोगे? 15 by 100 into 20 root 2. Now this will become this 3 root 2. Root 2 का value is how much? 1.412 something. So this will become around 4.2 kg meter second. So correct answer will be what? C. Okay. Now let's do this question. Again, this is a question from Impulse itself. So take 1.5 minutes of time and let me know the answer. Who is this Gen V Easy 2? कहाँ से पहुंच गए? तुम लोगों को तो पढ़ना ही नहीं है ऐसा फील होता है. Nobody is in the class. This is such a pathetic situation. This talks about the students' mentality these days. When you are getting something for free now, something for no cost, something without being asked for, then you value things like this. जिस तरह से तुम अभी value कर रहे हो, है ना? So this is really very sad situation actually. We don't understand the value of things until it is gone. And it will be gone, just you wait for some 10 or 12 months. You know, after that, we won't be gone. We will be still teaching to students like you who will not understand the value of it. But you will be gone out of your school and you will realize what you missed and what you could have used in more better way. Okay? So this is really a very pathetic situation. I really feel bad for you people. कि तुम लोगों की सोच में अभी तक ये प्रॉब्लम है और कैसे. आई डोंट नो. यस मैम तो बोल रहे हो बट लेट क्यों हुआ ये बताओ मुझे. I really don't want to make you feel bad, but I'm just telling you the truth, the reality, you know. ठीक है. Do this question. I have taught in Navodaya school. I have been in Navodaya school actually, and for some 4 years. So I have seen the environment. I know what happens. In class 11th, their only duty is to take care of Ganesh Chaturthi, Saraswati Puja, all sort of functions that is happening, be it Teachers' Day, Children's Day, or whatever that is your farewell. Pressure तो नहीं होता. Farewell used to be there, or क्या क्या होता है somewhere you go for playing and all. I strongly support कि you should participate, you should enjoy also. At the same time, you should be taking care of your classes, your courses, है ना? अभी क्या है 6th क्लास स्टूडेंट्स का कुछ ऐसा कुछ एडमिशन चल रहा है. स्टूडेंट्स you people are engaged there. You should talk with your teachers. You should tell them कि what I'm missing during this period when I'm doing this work. So you should learn to prioritize. Simple सी चीज है. तुम्हारी priority क्या है? According to that, you should distribute your time. It's that simple. Okay, let me know the answer now. Just now I have told you impulse कैसे निकालते हैं. Impulse is your FDT, right? And that is change in momentum. Here in the question, it's not talking about initial final velocity. Nothing is given like that. We can't calculate, but here graph is given. And graph is your what? It is force versus time. So I also taught you in the class that how to deal with the graph. ग्राफ का स्लोप का क्या मतलब होता है, एरिया का क्या मतलब होता है. सो आई हैव टोल्ड यू इफ दिस इज y वर्सेस x का ग्राफ. सो स्लोप मींस व्हाट? स्लोप मींस dy by dx, that is y by x, and area of graph means what? Y dx. Done. So here along y axis it is a, along time axis it is t. So area of this graph will be equal to what? F dt, sum of all f dt, है ना? So if you are going to sum this y dx, we will get area of whole. If this is the graph, then this whole area. Similarly here, if we are going to calculate area, then we will get value of f dt in aggregate, total f dt we will get, and that we have to calculate here. Impulse, that is the change in momentum निकालना है, change in momentum of particle over the interval from 0 to 8. ठीक है. सो if dt is equal to what, अभी अभी मैंने तुम लोगों को बताया था कि if dt is equal to what, dt. So if you have to calculate change in momentum over 0 से 8 second, so what you will do, you will add f dt from 0 to 8 second. That you will do, right? And 0 to 8 second summation of f dt from 0 to 8 second means area of this curve given from 0 to 8 second. तो अब आप एरिया निकाल दो, इसका एरिया निकालो, इसका एरिया निकालो, इसका एरिया निकालो. तो फर्स्ट का एरिया क्या होगा मुझे बताओ. फर्स्ट का एरिया विल बी योर A1, बुला लो इसको. फर्स्ट इज योर ट्रायंगल, सो हाफ बेस इनटू हाइट, है ना. एंड दिस half base value is how much, 2, height is how much, 6. So this is your 6. Now calculate A2. A2 क्या है तुम्हारा, एक ट्रायंगल नहीं है, एक रेक्टेंगुलर जैसा स्ट्रक्चर है. एंड इट्स width is how much, it is -3 and length is how much, that is your 4 minus 2, that is 2. ठीक है. So 2 into -3, it is how much, -6. Again माइनस साइन तुम्हें लेना है, that is very important. यहाँ पे if it is -3, then don't calculate area as 3 into 2. Modulus नहीं लेना है. With proper sign we have to calculate the area. Now A3 you calculate. So A3 is also a rectangle. 8 minus 4, that is your 4 into this is your 3, so 3, 12. If you're going to add whole area, this will get cancelled, and only total value of the area under curve is how much, from 0 to 8 second, it is 12. Done. So answer will be 12 Newton second. So this is your correct answer. Okay, this is how we calculate change in momentum or impulse. Now do this question. Take some 1.5 minute again and do it. You should invest your time in reading and discuss question with your friends, with your teacher, with me, whenever you get time, and invest yourself in studies. I know there are so much to do beyond the studies also, that I know, but you know what is the thing? You being in a Navodaya setup, you're not like professionally involved in other things, like playing things also. If you're doing once in a year, you're going somewhere to play, or once in 6 months you're going. That is not how professionally you become a player or a singer or a dancer. For that, you need to do that thing also on daily basis. You need to do practice for 8 hours, 9 hours, 10 hours. So everything requires dedication. And in your hand right now, only available options to read. So make best of this one. And after going into college, you can explore again different things if you feel like. So अभी समझदारी इसमें है कि जो हाथ में है उसको कैच करो. So give your time to studies. Impulse निकालनी है तुम्हें, ठीक है? Let me know the answer. I'm waiting in the chat box. Answer is right or wrong, that doesn't matter. You are trying, that matters. Okay. So let me know what you're getting. No answers? You can do it. You're from which MBA? This is easy too. Can you let me know the full form? Okay, please text me in the chat box. In between, I'm explaining the question. There is a rigid ball of mass same strikes a rigid wall at 60 degrees and gets deflected without loss of speed as shown in the figure. Right? So it is striking the wall with velocity v. It is after striking the wall, it is going away like in this direction with the same velocity. Done. The value of impulse imparted is what? Done. So here what is happening? You can see that initial momentum in this direction is how much? mv. Done. And okay, b. Yeah, that's correct answer. Very good. So initially, if you're thinking like in this direction, momentum is mv, and final in this direction, momentum is what? Answer is not correct actually, but still you tried. So, and in this direction, momentum is how much? mv. So, how 2 mv you're getting, I don't know. Maybe you are feeling like in this direction it is mv, this direction is mv. So this direction you are taking as positive and this one as negative. You are finding out the difference perhaps. I don't know. So let's see what is happening. चलो मैं wall को ऐसे बनाती हूँ. What is happening? Ball is coming like this, है ना? So in this direction, ball is coming, and what will happen when ball will hit the wall? It will feel the force from wall. That is, collision will happen between ball and wall. Between ball and wall, collision will happen, and during this collision what will happen? Force will get applied in between these two bodies. अब देखो force कैसे लगेगा? wall इस पे force कैसे लगाएगा? In this direction it will apply force, है ना? Then you can see here clearly wall will apply force in this direction. And in collision, you all must have studied one thing, that is your line of impact. इस क्वेश्चन को मैंने इसलिए इंक्लूड किया था. This is very important. जैसे अभी तुम लोग ध्यान से सुनो, यहाँ पे एक बॉल A है and this is moving with velocity v1, and here ball B is there. It is moving with velocity v2. Suppose कर लो v1 is greater than v2. What will happen? A and B will collide. So if they are colliding, what is happening? Like this, they are meeting. And force is acting along this direction. Ball A will apply force on ball B in this direction. And from Newton's third law, B will apply force on A in this direction. So two colliding bodies apply force on each other. और जिस direction में force लगता है, that is your line of impact. ठीक है? ऐसा नहीं force इस direction में नहीं लगा रहा है A B पे. Force is acting along this direction. So how you will draw the line of impact? So that is basically just take the center of mass of two bodies and draw a line through it. So A ka center of mass will be where? A ka center of mass is where? Here. And B ka here. So line joining these two is your line of impact. Okay? And momentum change along line of impact. ठीक है? Momentum change, अभी तक तुमने जितना भी पढ़ा है ना, initial momentum is equal to final momentum in which direction? Along line of impact. Okay. So again, if you are going to calculate impulse, that is your f dt equal to delta p. So f dt, if you are calculating, then it can be equal to change in momentum. Again, change in momentum in which direction? Along line of impact. So when you are calculating delta p, just have in your mind ki where is the line of impact? Along that direction you have to go with. Done. So here we have to calculate impulse. We will calculate momentum in which direction? Along line of impact. Here force is acting in this direction. So this is my line of impact. Done. So along this direction we have to deal with. अब चलो easily निकालते इसको. So this is initially ball is in this direction, velocity is v, line of impact is this. So initial momentum along line of impact is how much? This angle is how much? 60 degree. So initial momentum in this direction is how much? mv. In this direction it will be how much? mv cos 60. So initial momentum अगर मैं लिखूं, तो that is your how much? mv cos 60 by 2 हो जाएगा. Cos 60 is half. and this is in minus j cap direction. चलो मैं इसको downward y लेती हूँ. So this is this. P final will become how much? Finally, ball is going on like this with velocity v. So final momentum along line of impact will be in this direction, and that is mv cos 60 again. So that is your mv by 2 in j cap direction. So if you're going to calculate delta p, that is pf minus pi, and that is equal to mv. है ना? So correct answer will be what? mv, not 2m. ठीक है? क्योंकि we have to calculate change in momentum along line of impact. What is line of impact? Line along which force will act during collision. And how we will draw line of impact? So simply we have to take the center of mass of two colliding bodies, just join them, that will be your line of impact. ठीक है? चलो. So एक चीज और मैं बता दूं, जितने भी तुम लोगों ने कोलिजन में पढ़ा है ना, इनिशियल मोमेंटम इज इक्वल टू फाइनल मोमेंट, ये किसके अलोंग करते हो? लाइन ऑफ इम्पैक्ट. वेलोसिटी ऑफ सेपरेशन बाय वेलोसिटी ऑफ अप्रोच. वेलोसिटी ऑफ सेपरेशन बाय वेलोसिटी ऑफ अप्रोच किसके बराबर होता है? कोएफिशिएंट ऑफ रेस्टिट्यूशन. ये वेलोसिटीज तुम किस डायरेक्शन के अलोंग ले रहे हो? लाइन ऑफ इम्पैक्ट. ठीक है? So this is very important. Now do this. Take some 1.5 minutes and let me know what answer you're getting. Under laws of motion, we deal with forces. Okay. So just right now we are dealing with force acting during collision. After that, we will deal with tension force, friction force. So laws of motion. For laws of motion, I will be taking number of classes. Don't worry. Done. So I will explain different tricks that you need to know to solve this question very easy. Done. Now do this question and let me know what answers you're getting. I'm giving you a hint here. An object flying in the air with velocity this suddenly breaks into two pieces whose masses are in the ratio this. Okay. So we have a big body, and this big body is breaking into two small parts. One part is having mass, like their masses are in ratio what? 1:5. So if ratio is 1:5, we can solve it like, let's assume this big body has a mass of 6m, then this will have mass of m, and this will have mass of 5. Then their ratio will be what? 1:5, right? So we can easily make it like this. So initially this body has momentum of what? Sorry, velocity of what? This much. So it will have momentum also m into v, that is 6m into v in I cap direction, j cap direction, k cap direction. When something breaks, why it breaks? It breaks because of internal forces. And when force is internal, momentum will be conserved. Done. So whatever is the initial momentum of this 6m will be equal to momentum of these two masses together. Okay. So use this and try calculate. what you are getting. Just see here, what is the momentum of 6m mass? So initial momentum I'm writing, mass is 6m, velocity is how much? 20 I cap plus 25 j cap minus 12 k cap. Final momentum will be what? Momentum of m mass and momentum of 5m mass. ये कितना होगा? क्वेश्चन में देख लो, एक की वेलोसिटी दी हुई है, स्मॉलर मास फ्लाइज ऑफ विद दिस वेलोसिटी, so m into 100 I cap plus 35 j cap plus 8 k cap you will write. Plus क्या करोगे? Momentum of 5m mass. So what will be its momentum? So its mass is 5m, its velocity is not given. So let's assume its velocity is x I cap, y j cap plus z k cap. Done. So this pi should be equal to pf. It means what? X component of I component of momentum, initial I component of momentum should be equal to final I component of momentum. So finally momentum along I direction is how much? 100m plus 5mx. So along x direction, if I talk about, final initial momentum is how much? 6m into 20. Final momentum is how much? 100m plus 5mx. एक काम करो, m को कैंसिल कर दो हर जगह से. This is 120, this is 100, so this is 25x. So x is how much? X we are getting as 4. Now deal with similar way, deal with y direction. So initial momentum in y direction is how much? That is your 6m into 25, and that is equal to how much? 35m plus 35m plus 5my. Similarly, you can calculate y also. Na? 25 into 6 will be equal to how much? It will be equal to how much? 150. So 150 minus 35 is equal to 5y. So y will become equal to what? 23. And you don't need to solve all actually. Let us look at the option. In option 1, velocity along x direction is 4. And we got for x 4 only. Done. So this is correct. In none of these three options, x component of velocity is given as 4. It means only first is the correct. Done. So the correct answer will be what? Correct answer will be your A. So I hope you all understood whatever I taught, but there were very few people in the class. Anyway, I expect more engagements in further classes. This is for you, and so you should be present here. I don't know why people are not here. Anyway, JNV easy too. I just asked the name of this JNV. क्या है? नाम बता दो. If you're comfortable enough, I don't think there is any problem in telling me the name of this Navodaya. Is there any problem? Okay. Okay, no way, no worries. So this is all for today's class. In next class, again, I will be dealing with laws of motion only. Done. And there we will be dealing with various other kind of forces. That is your tension, friction, and normal. So many forces we will be dealing with. We will deal with free body diagrams and everything. So let's meet ahead in future classes. And all the best for your midterm exam. Do prepare properly. Give your exam honestly. और पढ़ाई करो अच्छे से और enjoy भी करो. ठीक है? So bye bye. Take care. Stay safe and keep reading. Bye.